Managing large files in a source control system is a critical aspect of DevOps. Traditional version control systems like Git are not optimized for handling large files, which can lead to performance issues and bloated repositories. This presentation will delve into strategies for managing large files effectively, focusing on tools like Git Large File Storage, LFS, and Git Fat. By the end of this presentation, you will understand the challenges of managing large files and how to overcome them using these specialized tools. Git is designed to handle small to medium-sized files efficiently. However, when it comes to large files, Git can struggle. Large files can slow down repository cloning, increase storage costs, and make version history cumbersome. These challenges necessitate a specialized approach to managing large files, ensuring that the performance and efficiency of the version control system are maintained. Git Large File Storage, LFS, is an extension for Git that replaces large files with text pointers inside Git while storing the file contents on a remote server. This approach allows you to manage large files without compromising the performance of your Git repository. Git LFS is particularly useful for projects that involve large media files, datasets, or any other type of large binary files. Git LFS works by replacing large files in your repository with small pointer files. These pointer files reference the actual content, which is stored on a separate server. When you clone a repository that uses Git LFS, the pointer files are downloaded first, and the actual large files are fetched as needed. This reduces the amount of data transferred during cloning and improves overall performance. To set up Git LFS, you need to install the Git LFS extension and configure your repository to track specific file types. This involves running commands like git lfs install and git lfs track file type. Once configured, Git LFS will automatically manage the large files in your repository, ensuring that they are stored efficiently and do not impact the performance of your Git operations. Git Fat is another tool designed to handle large files in Git repositories. Unlike Git LFS, which uses a dedicated server for storing large files, Git Fat allows you to use various storage backends, including cloud storage services like AWS S3. This flexibility makes Git Fat a versatile option for managing large files in different environments. Git Fat works by replacing large files in your repository with small placeholder files. These placeholders reference the actual content, which is stored in a separate storage backend. When you need to access the large files, Git Fat fetches them from the storage backend and replaces the placeholders with the actual content. This approach ensures that your Git repository remains lightweight and efficient. Setting up Git Fat involves installing the Git Fat extension and configuring your repository to use a specific storage backend. This typically involves running commands like git fat init and git fat push. You also need to configure your storage backend, which could be a cloud storage service or a local file system. Once set up, Git Fat will manage your large files, ensuring that they are stored efficiently and do not impact your Git operations. Both Git LFS and Git Fat offer solutions for managing large files in Git repositories, but they have different approaches and use cases. Git LFS is more straightforward and integrates seamlessly with Git, making it a good choice for most projects. On the other hand, Git Fat offers more flexibility in terms of storage backends, making it suitable for projects with specific storage requirements. Understanding the strengths and weaknesses of each tool will help you choose the right solution for your needs. When managing large files in a Git repository, it's important to follow best practices to ensure optimal performance. This includes regularly cleaning up your repository to remove unused large files, using appropriate file tracking patterns, and monitoring the size of your repository. Additionally, consider using tools like Git LFS or Git Fat to offload large files to external storage, keeping your repository lightweight and efficient. Let's look at a case study where a software development team implemented Git LFS to manage large media files in their project. The team was facing performance issues due to the size of their repository. By implementing Git LFS, they were able to offload the large media files to a separate server, significantly improving the performance of their Git operations. This case study highlights the practical benefits of using Git LFS for large file management. In another case study, a data science team used Git Fat to manage large datasets in their Git repository. The team needed to store their datasets in AWS S3 for cost and scalability reasons. By configuring Git Fat to use S3 as the storage backend, they were able to efficiently manage their large datasets without impacting the performance of their Git repository. This case study demonstrates the flexibility and effectiveness of Git Fat for large file management. Managing large files in a Git repository is a common challenge, but with the right tools and strategies, it can be effectively addressed. Git LFS and Git Fat offer robust solutions for offloading large files to external storage, ensuring that your repository remains lightweight and efficient. By understanding the strengths and use cases of each tool, you can choose the best solution for your project. Implementing best practices for large file management will further enhance the performance and maintainability of your Git repository.